Welcome to Spaceverse, your portal to cosmic adventures. It's been 2 years since NASA's James Webb Space Telescope gave us an incredible first look at the far reaches of the universe, and the results are beyond anything we could have imagined. NASA just unveiled new images from Webb, and they're not just beautiful, they're downright chilling. These images reveal a universe that's more chaotic and mysterious than we ever thought, including a cosmic collision that could one day mirror the fate of our own galaxy. But these images aren't just about what's out there. They raise some big questions about our place in the universe. Let's dive deeper into these revelations and uncover the unsettling truths they might hold. The journey of the James Webb Telescope. NASA's goal was simple. They wanted to peer further into space than ever before, pushing past the limits of the Hubble Space Telescope. Enter the James Webb Space Telescope, humanity's ultimate tool for exploring the cosmos. This telescope was built to study galaxies over 13 billion years old, right after the Big Bang. That's way older than your great-great-grandparents times a billion. But when Webb's first images came back, they showed something unexpected, signals that didn't quite match what we thought we knew. The truth could completely change everything about our understanding of the universe. This telescope wasn't built overnight. It took decades of research, design, and countless hours of hard work from experts who dedicated their careers to it. NASA worked hand in hand with the Canadian and European space agencies to make it happen. And here's a fun tidbit. This telescope didn't come cheap. We're talking billions of dollars, all to capture tiny dots of light billions of miles away. The James Webb Space Telescope launched into space about 3 years ago and set up shop nearly 930,000 miles from Earth. That's so far, it's hard to even picture. Unlike most satellites that orbit Earth, Webb is positioned at the Sun-Earth Lagrange point, a cosmic sweet spot where gravitational forces balance out perfectly. One of the latest images was dubbed the Penguin and the Egg, because scientists love giving poetic names to the mysterious blobs of light they discover. Let's dive into the impressive hardware of the James Webb Space Telescope, because this isn't your average piece of tech. Its primary mirror is a massive 6.5 meters wide, made up of 18 golden hexagonal segments. Why gold? Because it's perfect for reflecting infrared light, the kind of light we can't see, but Webb is all over it. Picture it as a giant, shiny sunflower peering into the cosmic unknown. But wait, there's more. Enter the sunshield. This 5-layer marvel is the size of a tennis court and is the ultimate space sunscreen. Its job? To keep the telescope cool by blocking out the sun's intense heat. And it does this job so well, it keeps temperatures down to a mind-blowing minus 233 degrees Celsius. That's colder than your freezer by 100 times. Why does it need to stay so cold? Because Webb is all about infrared signals, tiny heat signatures from far-off galaxies. If the telescope weren't kept this chilly, those faint signals would be completely drowned out. Thanks to the sunshield, Webb can spot even the faintest glimmers of heat from objects billions of light years away. And then we've got the scientific instruments. There's a near-infrared camera, a mid-infrared instrument, and a few other high-tech gadgets designed to collect and analyze light. With these tools, scientists can study everything from newborn stars to the atmospheres of planets light years away. In other words, the James Webb Space Telescope is like the Swiss Army knife of space exploration, equipped to tackle anything the cosmos throws its way. The images sent back by the James Webb Space Telescope aren't exactly what our eyes would see. These are data captured from light in wavelengths beyond our vision, which scientists then translate into colors we can understand, like turning radio static into a beautiful melody. The results are stunning, but they also leave us with a sense of unease. With each new image, more questions arise. Take the penguin and egg images, for example. At first glance, they seem playful, almost whimsical. But upon closer inspection, strange shapes and unusual light patterns stir up curiosity and a bit of discomfort. These images hint at forces and phenomena we don't fully grasp yet. Are they just natural cosmic events, or are they glimpses into something far beyond our understanding? The mystery doesn't stop with one image. Since its launch, Webb has been uncovering jaw-dropping sights. Galaxies are spinning in spiral formations. Stars are behaving in ways that challenge our current knowledge. Water vapor has been detected on planets that could potentially support life. Each discovery feels like a cosmic puzzle, pushing humanity to dig deeper into the mysteries of the universe. The discoveries made by the James Webb Space Telescope carry significant weight. As we deepen our understanding of the universe, we also grow more aware of Earth's fragility. Gazing at distant galaxies fills us with awe, but it's also a humbling reminder of just how small we are in the vast cosmos. While these revelations may not scream immediate danger, they certainly provoke deep thought. If we're not alone in the universe, what does that mean for us? And if other life forms exist, should we be cautious about drawing their attention? The James Webb Space Telescope is more than just a tool for exploring the cosmos. It's a mirror reflecting both the magnificence and vulnerability of life on Earth, encouraging us to reflect on the mysteries yet to be uncovered. But let's keep digging deeper. The James Webb Space Telescope doesn't just provide pretty pictures, it offers profound revelations. Each image, each dataset is like a breadcrumb guiding scientists closer to unlocking the secrets of the universe. This is poised to be the next big leap in astrophysics. Take, for example, the telescope's ability to peer into the dusty regions of space where stars are born. These star-forming areas are like cosmic nurseries, and Webb's infrared capabilities let us look past the haze to witness the birth of stars. Webb's focus isn't limited to distant galaxies. It's also giving us a closer look at exoplanets, planets outside our solar system. By analyzing the light that filters through their atmospheres, the telescope can detect molecules like water, methane, and carbon dioxide. These chemical signatures could be clues that life might exist elsewhere. Imagine finding a planet with conditions similar to Earth. This isn't just science fiction anymore. It's becoming a real possibility. Building a telescope for space? That's no easy feat. Every detail had to be flawless. The James Webb Space Telescope's mission to unravel the universe's mysteries is full of challenges. Operating so far from Earth leaves zero room for error. From its gold-coated mirrors to the complex sun shield, every piece was designed to perfection. Once it's up there, there's no fixing it, no repair crew on hand if something goes wrong. It's truly a marvel of human innovation that the telescope works so flawlessly in such a harsh environment. The universe is vast, mysterious, and endlessly captivating, and the James Webb Space Telescope gives us a front-row seat to the greatest cosmic show, watching the story of existence unfold before our eyes. From the smallest details of exoplanet atmospheres to the grandest galaxies far, far away, this telescope is changing how we understand the cosmos. But the Webb isn't just a tool for scientists, it's a shining symbol of our endless curiosity, our unquenchable thirst for exploration and understanding. And as it continues to peer deeper into space, who knows what secrets it'll uncover next? NASA has just released some jaw-dropping images from the James Webb Space Telescope, and let's be real, they're not only stunning, they're a little unsettling too. This isn't your average telescope snapping some nice moonshots. The Webb is looking back in time, showing us events that happened over 13 billion years ago, back when the universe was still figuring itself out. But don't panic and start Googling how to survive a cosmic disaster. Let's break it down without all the science mumbo-jumbo. First off, the James Webb Space Telescope isn't your backyard telescope. It collects light in wavelengths we can't even see. Then NASA uses advanced techniques to turn that data into images we can actually comprehend. And yes, this is the kind of stuff that keeps me up at night too. It's not just a simple point-and-click job. These images go through some serious digital magic. They filter out the noise, combine different exposures, and sharpen every detail from stars to galaxies until they're crystal clear. It's like editing a photo, but instead of a picture of your dog, it's a photo of the entire universe, and it takes cutting-edge computer power and expert skills to make it happen. Here's where it gets really wild. The James Webb Space Telescope isn't just capturing stunning pictures. It's like a cosmic time machine. By catching light that's been traveling for over 13 billion years, it's giving us a glimpse into how the universe began. But instead of showing the Big Bang itself, It's revealing galaxies and stars that formed just a few 100 million years after the explosion. It's like looking at the universe's baby photo, except this baby's been sitting in a cosmic album for billions of years. To make this happen, NASA launched Webb on December 25, 2021, after what felt like an eternity of planning and preparation. The rocket, provided by the European Space Agency, blasted off from a spaceport in French Guiana. The stakes were sky high, there was absolutely no room for mistakes. But it worked. Webb made its way to its new home, a spot known as the second Lagrange point. This prime location lets the gravitational forces of the Earth and Sun cancel each other out, keeping the telescope in place without wasting fuel. Once there, Webb had to unfold itself like a piece of cosmic origami. Its giant sun shield deployed to block heat from the sun, and its mirror, basically the telescope's eye, aligned perfectly. It wasn't just cool to watch. It was nerve-wracking. One wrong move and billions of dollars in science could have been lost. But everything worked out, and by July 2022, NASA unveiled Webb's first official images. These weren't just ordinary photos. The very first one was a deep-field image showing galaxies billions of light-years away, light that's been traveling since before Earth even existed. Another image captured the Southern Ring Nebula, where a dying star is putting on a stunning light show. There was also a picture of Stephan's Quintet, a group of 5 galaxies hanging out together about 290 million light-years from Earth. Each of these images isn't just beautiful. They hold tons of information about how stars and galaxies form, evolve, and eventually fade away. So, what makes Webb so special? Why couldn't the Hubble Space Telescope do all of this? Well, Hubble's been our trusty space photographer since 1990, orbiting Earth about 310 miles above us and capturing some of the most iconic space shots. But Hubble mainly works in visible and ultraviolet light, which is great for certain things, but doesn't cut it when it comes to peering through cosmic dust or seeing the faintest, oldest objects in the universe. Webb has focused on infrared light, a key tool for cutting through dust and revealing what's hidden in the depths of space. Essentially, Webb and Hubble are like teammates, each with unique strengths. But when it comes to exploring the universe's deep history, Webb is undoubtedly the MVP. While the universe appears calm and majestic in those stunning images, what they truly show is a realm of constant turmoil and transformation. Stars are born, live, and die. Galaxies collide and merge. And black holes sit at the heart of it all, devouring anything that ventures too close. It's a humbling reminder that our small planet is just a speck in a universe that has existed for billions of years and will likely continue long after we're gone. Webb's discoveries aren't just impressive, they're reshaping our understanding of our place in the cosmos. Through Webb's golden mirror, the telescope is doing more than just snapping beautiful pictures. It's rewriting the story of the universe's origins and its future, raising profound questions about life, time, and the nature of everything around us. It's both awe-inspiring and a bit unsettling, but isn't that what makes it so exciting? Since its launch, the James Webb Space Telescope has made groundbreaking discoveries, unveiling images that have left scientists puzzled. These photos reveal scenes from the farthest reaches of space that challenge existing knowledge and ignite curiosity about the unknown mysteries of the universe. The question now is, are we ready to face what lies beyond? Webb stands out for its extraordinary capabilities. Unlike the Hubble Space Telescope, which has been a trusted tool for space exploration for decades, Webb offers a revolutionary leap in technology. Its massive gold-coated mirror, over 21 feet wide, enables it to capture even the faintest and most distant objects with unmatched precision. This advanced design also allows Webb to detect infrared light stretched by the expanding universe, in a way no other telescope can. In contrast to Hubble, which mainly observes visible and ultraviolet light, Webb's ability to detect infrared light gives it a significant advantage in exploring the farthest reaches of the universe. These recent breakthroughs emphasize the transformative impact of the James Webb Space Telescope. Its ability to peer deeper into space is not only expanding our knowledge, but also changing humanity's understanding of our place in the vast cosmos. One key advantage of Webb is its location. While Hubble orbits Earth and faces interruptions from sunlight and the planet's glare, Webb is positioned over 1 million miles away at the second Lagrange point, where it remains shielded from heat and light. This unique position allows Webb to stay extremely cold, making it ideal for detecting faint infrared signals. In short, Webb operates in the perfect environment for its mission to reveal the hidden corners of the universe. Hubble has given us stunning views of space, but it's not capable of observing the earliest galaxies formed after the Big Bang. Webb, on the other hand, can detect faint infrared light and peer back more than 13 billion years, capturing images of the universe's earliest moments. Hubble's smaller mirror and limited wavelength sensitivity simply can't achieve this. One of Webb's most intriguing recent images, nicknamed the Penguin and the Egg, depicts a dramatic interaction between two galaxies, ARP 142, located over 300 million light-years away in the Hydra constellation. The Penguin is a distorted spiral galaxy, or NGC 2936, that's been pulled and twisted by a close encounter with a compact elliptical galaxy, or NGC 2937, the Egg. These galaxies have been locked in a gravitational dance for millions of years, and their interaction has created a stunning visual, with the Penguin's spiral arms resembling a bird's head and beak. This cosmic collision offers a preview of the fate of galaxies like our own Milky Way, which will eventually merge with the Andromeda Galaxy. Over the next few 100 million years, these two galaxies will merge into one, triggering bursts of star formation as their gases compress. The Egg, however, remains relatively unchanged due to its older gas-poor composition. This collision is more than just a captivating image. It's a window into the future of galactic evolution. Webb's observations of these distant galaxies also allow us to see light that's traveled across the universe for nearly its entire history. Beyond galaxies, Webb is playing a key role in studying exoplanets, or planets orbiting stars outside our solar system. By analyzing the atmospheres of these distant worlds, Webb has detected molecules like water vapor, carbon dioxide, and others, suggesting that life could be possible elsewhere. One notable discovery was the detection of water in the atmosphere of the gas giant WASP 96b. Though this planet is far too hot to support life, the finding showcases Webb's extraordinary sensitivity and brings us closer to identifying planets capable of supporting life, an exciting step forward in the search for extraterrestrial worlds. The telescope's accomplishments extend far beyond exoplanets. It's revolutionizing our understanding of how stars and planets form. By peering into regions like the Carina Nebula, Webb offers unparalleled views of stellar nurseries where new stars and planetary systems are born. These detailed observations are giving astronomers valuable insights into the intricate processes that shape the universe. Webb is also focused on the mysterious world of black holes. By observing the centers of distant galaxies, it's captured striking evidence of energy jets emitted by supermassive black holes. These powerful jets play a crucial role in the growth and evolution of galaxies, and Webb's findings are shedding light on the complex relationship between these colossal objects and their galaxies. And that's it. Thanks for watching Spaceverse. Webb's discoveries are reshaping how we see the universe. Like, comment, and subscribe for more cosmic insights. See you next time.